Our planet is warming, glaciers are melting, sea levels are rising, the signs are all around us, and they are becoming increasingly difficult to ignore. The ice that has stood for millennia is now vanishing at an alarming rate, a clear indicator of the changes our world is undergoing. These are not mere predictions, they are the stark realities of climate change, fueled by our insatiable hunger for energy. Coastal cities are facing unprecedented flooding, and communities are being displaced. The impact is not just on the environment but on human lives and livelihoods. The burning of fossil fuels, the backbone of our modern civilization, releases harmful greenhouse gases into the atmosphere, trapping heat and disrupting Earth's delicate climate balance. This relentless pursuit of energy has led to air pollution, health problems, and a warming planet that threatens our very existence. The consequences are already being felt worldwide, from extreme weather events to disruptions in food production. Hurricanes are becoming more intense, droughts more severe, and floods more frequent. Farmers are struggling to grow crops, and food security is at risk. We are living in a time of unprecedented environmental challenges. Deforestation is stripping the planet of its lungs, rivers are choked with pollution, and our oceans are drowning in plastic waste. The natural world is under siege, and the need for action has never been more urgent. The need for a sustainable and clean energy source is more urgent than ever before. Renewable energy technologies like solar, wind, and hydroelectric power offer a glimmer of hope. They provide a path to a cleaner, healthier future, free from the shackles of fossil fuels. The future of our planet, and indeed our very survival, hinges on our ability to transition away from fossil fuels and embrace clean, renewable energy sources. Electric vehicles, energy-efficient buildings, and innovative technologies are paving the way for a sustainable tomorrow. The time for action is now. People from all walks of life are coming together to demand change. Scientists are tirelessly working on solutions, and communities are taking steps to protect and restore our environment. The collective effort of humanity can turn the tide and secure a future for generations to come. Nuclear energy has long been touted as a potential solution to our energy woes. Unlike fossil fuels, nuclear power plants produce electricity without releasing greenhouse gases into the atmosphere. They are highly efficient, capable of generating vast amounts of power from relatively small amounts of fuel. However, traditional nuclear reactors, which rely on uranium as fuel, have faced significant challenges and public opposition. Concerns about safety, the risk of meltdowns, and the disposal of radioactive waste have cast a long shadow over the nuclear industry. But what if there was a way to harness the power of nuclear energy without the risks associated with uranium-based reactors? What if there was a safer, cleaner, and more sustainable path to nuclear power? Enter thorium, a silvery white metallic element found in abundance in the Earth's crust. Thorium itself is not fissile, meaning it cannot sustain a nuclear chain reaction. However, when bombarded with neutrons, thorium transforms into uranium-233, a highly fissile isotope that can be used as fuel in a new generation of nuclear reactors. Thorium reactors offer several advantages over their uranium counterparts. They are inherently safer, produce significantly less radioactive waste, and pose a lower risk of nuclear proliferation. Thorium could be the game-changer the nuclear industry has been waiting for. Could this relatively unknown element hold the key to unlocking a future of clean, safe, and abundant energy? The differences between thorium and uranium reactors are significant and far-reaching. Uranium reactors produce plutonium as a byproduct, a highly radioactive material that can be used to make nuclear weapons. Thorium reactors, on the other hand, do not produce plutonium in any significant quantities, greatly reducing the risk of nuclear proliferation. Moreover, the waste generated by thorium reactors is far less radioactive and decays to safe levels much faster than uranium waste. This means that the long-term storage and disposal of nuclear waste, a major concern with uranium reactors, becomes a less daunting challenge with thorium. The inherent safety, reduced waste, and non-proliferation benefits of thorium make it a compelling alternative to traditional uranium-based nuclear power. Section 5. Safety first. The inherent advantages of thorium. One of the most compelling advantages of thorium reactors lies in their inherent safety features. Unlike uranium reactors, which require complex and expensive control systems to prevent meltdowns, thorium reactors are inherently resistant to runaway chain reactions. The nuclear reaction in a thorium reactor can be easily stopped by simply stopping the flow of neutrons. This passive safety feature makes thorium reactors much less prone to accidents and meltdowns, a major concern with traditional nuclear power. The inherent safety of thorium reactors could help to alleviate public concerns about nuclear power and pave the way for a wider acceptance of this clean energy technology. Section 6. Waste not, want not, thorium's minimal waste legacy. The disposal of radioactive waste is one of the most challenging aspects of nuclear power. Uranium reactors produce high-level radioactive waste that remains dangerous for thousands of years, requiring careful storage and disposal in deep geological repositories. Thorium reactors, in contrast, produce significantly less waste, and the waste they do generate is far less radioactive and decays to safe levels much faster than uranium waste. This means that the long-term storage and management of thorium waste is a much more manageable challenge. The reduced waste profile of thorium reactors is a major environmental advantage, making it a more sustainable and publicly acceptable form of nuclear power. Section 7. China takes the lead, the world's first thorium reactor. While thorium reactor technology has been around for decades, it is China that has taken the lead in developing and deploying this promising energy source. Thorium, a slightly radioactive metal, has long been considered a potential alternative to uranium for nuclear power. Its abundance and safety advantages make it an attractive option for sustainable energy. In 2021, China made history by starting up the world's first commercial-scale thorium reactor, a molten salt reactor located in the Gobi Desert. This reactor uses molten salt as both a coolant and a fuel, which allows it to operate at higher temperatures and lower pressures than traditional reactors, increasing its efficiency and safety. The successful deployment of this pilot reactor marks a significant milestone in the development of thorium technology and could pave the way for a global shift towards thorium-based nuclear power. This achievement demonstrates the potential of thorium reactors to provide a cleaner, safer, and more sustainable form of nuclear energy. China's ambitious plans to expand its thorium reactor program signal its commitment to becoming a leader in this emerging field. The country has outlined a roadmap for scaling up thorium reactor technology, with plans to build several more reactors over the next decade. This expansion could significantly boost China's energy security and reduce its reliance on fossil fuels. China's pioneering efforts in thorium reactor technology could have profound implications for the future of global energy. If successful, these reactors could revolutionize the nuclear power industry, offering a viable alternative to traditional uranium-based reactors. This could lead to a more sustainable and environmentally friendly energy landscape worldwide, with China at the forefront of this transformative change. Section 8. A global energy revolution? The successful development and deployment of thorium reactors could have far-reaching consequences for the global energy landscape. The potential of this technology to provide clean, safe, and abundant energy has captured the attention of scientists, policymakers, and industry leaders worldwide. If China's thorium reactor program continues to prove successful, it could trigger a global race to develop and deploy this transformative technology. The economic and geopolitical implications of a shift towards thorium-based nuclear power are significant. Could thorium be the key to unlocking a new era of global energy security and sustainability? Section 9. The future of energy, a thorium-powered world? The future of energy remains uncertain, but thorium offers a tantalizing glimpse into a world powered by clean, safe, and abundant energy. Unlike traditional nuclear fuels, thorium is more abundant and produces less long-lived radioactive waste. This makes it an attractive option for sustainable energy production. While challenges remain in scaling up thorium technology and addressing public concerns about nuclear power, the scientific community is optimistic. Public perception of nuclear energy has been shaped by past accidents, but thorium reactors promise enhanced safety features that could change this narrative. The potential benefits of this transformative energy source are too great to ignore. Thorium reactors can operate at higher temperatures, increasing efficiency and reducing the risk of meltdowns. Additionally, they can be designed to consume existing nuclear waste, further mitigating environmental impact. As the world grapples with the urgent need to transition away from fossil fuels and mitigate the impacts of climate change, thorium reactor technology represents a beacon of hope. The shift to renewable energy sources like solar and wind is crucial, but thorium could provide a stable and reliable baseload power to complement these intermittent sources. Thorium reactor technology represents a beacon of hope. It offers a pathway to a future where energy is not only abundant, but also environmentally responsible. The collaborative efforts of scientists and engineers worldwide are driving this innovation forward. It is a testament to human ingenuity and our unwavering pursuit of a sustainable future. The development of thorium reactors is a global endeavor, with countries sharing knowledge and resources to overcome technical and regulatory hurdles. The journey towards a thorium-powered world has just begun, but the possibilities are vast and the stakes have never been higher. As we stand on the brink of a new energy era, the promise of thorium shines brightly, guiding us towards a cleaner, safer, and more sustainable future.